Hello everyone, my name is Jiacheng from ECE department, and this is my demo presentation. My project is a research and simulation of short polar code decoding algorithm. First off, let me introduce the background and the significance of the selected topic. So first of all, the background, the beginning of the information theory. In 1948, Shannon proposed the channel coding rhythm, um, a pioneering modern information theory. So far, people have been working hard to find a coding scheme that can reach the channel limit. During this period, with the in-depth study of channel coding theory, excellent coding has been proposed, like LDPC code, turbo code, and so on, but none of them can reach the channel limit. I can say it's far from the channel limit, but in 2008, Performance Idol um, proposed the polar code for the first time based on the phenomena of channel polarization. It's the first coding method that has been theoretically proven to reach the channel limit. And in 2016, the polar code became the final plan for signaling channel coding in the 5G control channel EMBB scenario and successfully entered the 5G Basic Communication Framework Protocol. In 2018, the world's first 5G system compliant with 3GPP standards and supporting protocols was officially released. So for the next part is about my research. First of all, I started essay decoder. Um, essay decoder is based on the log likelihood ratio. Take the local optimum and decode in order. So, uh, so the SC decoder is firstly it used the received signal Y1N here, and U1. They use this one to decode the U1 and gets the decoded U1 over here, and it use the decoded value U1 and Y and the signal together to decode the U2 and get the decoded value of U2 and use this U2 to decode U3. So it's like the decision formula and the credence formula is over here. And this picture is like the simulation of the essay I got from the MATLAB. So BLER means the block error rate. So the lower block error rate goes, the better performance it has. So we can say that the N with the N increasing, the block error rate goes lower, which means it has the better performance. And N is the length of the code. And here X, this one means the SNR. Um, so we can say with the SNR increase, it has the more better performance. And next part is SCL. SCL is actually like is built in multiple SC decoders. It's taking the global of the system best. So here are two simulation results I got from the MATLAB. And here are the parameters of those results. And here the decoder called CASCL is a little bit different from the SCL because it adds CRC sequence to the this algorithm. So here is the flow structure of the CASCL. So like the Euro decoder, firstly it got the message input here, but it adds a CARC encoder here, and then use the polar encoder and transmission here, and use the SCL as Euro. But here it get another CRC detector. So with those two CRC encoder and detector, it will greatly improve the performance. Like here, I got the simulation from the code, and here the parameter is literally the same of this one, but to compare with two pictures, we can easily to say that the CASL have the better performance, which is comes from those two CRC encoder and detector. For the next part is about BP encoder. So this encoder is based on the factor graph here. Is the log likelihood ratio is obtained by the information transmission of each set. And here is the simulation result from the MATLAB. So we can say it also with the increase of the SNR, it will have the better performance, and with the increase of the length of the code, it also have the better performance here. So the last part of demo presentation is the results and analyzation. So here is I run all those decoders on my laptop, so I got the speed of encoding um, of each encoders. So I set SNR equals 2.5 dB, and I test the different code length here. So from this table, we can see that the SC decoder is leading position here. Yeah, it's much faster than all of them because of it has the low complexity equals to n log n. So, and I think the second is the BP decoders here. It's also because of the its natural high concurrent structure, and also we can see that SCL and CASCL actually their speed are literally the same, and with the increase of L, it will make it slower. We can see here. Okay, so from these three pictures, it's used to compare the full decoders, and by using the difference n. Here, this one is 1024. Here is 5012, and this one is n equals to 256. So, in terms of the encoding accuracy, the performance of SA and BP decoders are way behind the other two decoders, as we can see here. Those two, not performance very well, but and we also it can be seen that when the channel quality is per the like with the increase of the SNR here, the efficiency of all the decoders is very poor. So how to improve the SNR in industry is very important. The decoding performance of all those 4 decoders is directly proportional to code length here to the n, right? So which can be attributed to the polarization phenomenon becoming more severe with the increase of the n. So however, the decoding performance of those decoders needs to be improved when the code length is short, like here. They all have the bad performance. So this is also a problem for the polar code need to be solved. So based on the speed and the performance and their power consumption, time delay, and other aspects, so we can draw a conclusion that CA as CL is the most superior decoders we have here. And also, I want to share a little bit about my code. So because I need a lot of time to run this code. So so like over here, um, is the result of SCL, and when SNR equals to 1, um, so like this row is SC. It's the result of SC. The only difference of SC and SCL is that the difference of the SNR actually. So you can change all those parameters over here. Right. So here is the result of the BP. Oh, and, and here are the result of CASCL over here. And I collected those data and I draw the uh, figure that you saw in the PowerPoint. So that's all. Thank you very much.